Hi class, in this video we will consider some example of evaluating some values of inverse trigonometric functions. So let's in this example, evaluate the value of sine of the inverse of sine at square root of 2 over 2. Solution. First, let I is the value of the inverse of sine at the square root of 2 over 2. And we want to find y. How to find y? By the definition of the inverse of sine, we have y is in the closed interval minus pi over 2 to pi over 2, and y satisfies the equation the sine of y equals to the square root of 2 over 2. We will solve these two conditions to find y. First, we consider the equation the sine of y equals the square root of 2 over 2. We know the square root of 2 over 2 is the sine of pi over 4. So we have the equation the sine of y equals the sine of pi over 4. And this equation is equivalent to y equals pi over 4 plus k times by 2 pi, or y equals pi minus pi over 4 plus l times by 2 pi, with k and l are in the set of integer c. Okay, and is equivalent to y equals pi over 4 plus k times by 2 pi, and y equals 5 times pi over 4 plus l times by 2 pi. KL is in the set of integers. So now we have y equals pi over 4 plus k times by 2 pi, or y equals 5 pi over 4 plus l times by 2 pi. And among these values, we must choose one value that satisfies y lies in the closed interval minus 2 over pi to pi to pi over 2. Minus pi over 2 to pi over 2. So we can choose because y lies in this closed interval. We can choose y equals pi over 4. So we have pi over 4 is the value of the inverse function of sine at the square root of 2 over 2. Pi over 2 is the value of sine to the power of minus 1 at 2 over 2. Next, we will consider another example. Evaluate the value of the inverse function of cos minus of the arccos. Arccos. We can write cos to the power minus 1, 0, or we can use arccos 0. Instead of reading the value of the inverse function of cos as 0, we will read arccos 0 for simpler. Okay. To find arccos 0, we let y equals 0. And then by the definition of equals 0, we do have y is in the closed interval, was it 0 to pi. You can see the definition of the inverse function of cos to have this, and we must have that cos y equals 0. And to find y, we will solve the equation cos y equals 0 and then choose a solution that lies in the closed interval 0 pi to have y. First, we solve the equation cos y equals 0, and we know this equation is equivalent to y equals yet 0 plus pi over 2 plus k pi times y pi, with k is in the set of integers z, and among these values we must choose a value which lies in the closed interval 0 pi, so we can choose y is pi over 2. Okay, so we have the arc cos 0 in another way, the values of the inverse function of cos 0 equals to pi over 2. Okay, pi over 2. Next, we will consider another example. Evaluate the value of the inverse function of tan at 1. Or we can use we can read simply arc tan 1. Okay. Solution. Let y is the value of the inverse of tan at 1 or arctan 1. Then, by the definition of the inverse function of tan, we have y must lie in the open interval minus pi over 2 to pi over 2. Pi over 2. And of course, the value of tan at y must be 1. And to find y, we must solve the equation tan y equals 1, and then choose one solution in the open interval minus pi over 2 to pi over 2. First, we solve the equation tangent of y equals 1. Tangent of y equals 1 gives us the solutions pi over 4 plus k pi, with k lies in the set of integers z. Yes, sir. And among these values, we can choose one value which lies in this open interval. And this value is pi over 4. You can see that pi over 4. So we have the value of the inverse function of tan at 1 or arctan 1 equals pi over 4. You can use your your calculator to check it. Okay. We stop this video here. If you have any question, please leave your comment under this video. I will answer. Thank you for watching.